to get from 8 to 32, from 32 to 128. Check multiplication. Is there something you can multiply by each time? Plug in 8 divided by 2, you get 4. Plug in 32 divided by 8, you get 4. 128 divided by 32, you get 4. So if the division works, it means you are multiplying by 4 each time, which means this is geometric. Okay, first 2 questions on your quiz. Any questions for me on that? All right, 3 and 4. This one says find the first and 7th terms of the sequence. Do you have to plug anything in to find the first term? It's there for you, okay? What could you plug in to find the first term? What number would you be plugging in? A 1. If you're finding the first term, you could plug in a 1. A sub 1 equals 3 times negative 2 to the 1 minus 1. What do you get as your power? What's 1 minus 1? 0. What is anything to the 0 power? It's 1. So this is really 3 times 1, which is 3. So you can do it that way, but you don't have to. It's always this number. It's always that A sub 1 number. Gentlemen, can we handle this? So your first term is 3. Your 7th term, you should plug the number 7 in. Now, you could, because you're multiplying by a negative 2 each time, that's what this negative 2 is saying, you could just go 3 times negative 2 times negative 2 times negative 2 times negative 2 7 times. But that's a lot more work than just plugging a 7 into your formula. So A sub 7, your 7th term, is 3 times negative 2 to what power? 6. 7 minus 1. Okay, so plug it in 3 times negative 2 to the 6th power. Use parentheses. What do you get? That should be 192. Okay. Do you know what the term after that would be? It's going to be a negative, right? Because you're multiplying by a negative 2 each time. So it's going to go positive, negative, positive, negative, positive. Well, it's going to go negative, positive, negative, positive. Okay. Number 4. What is your first term here? What's your first term? 4. It's this number. Okay, it is the number 4. You don't have to solve a thing. If you want to, you can go 4 times 5 to the 1 minus 1 power. So that's 4 times 5 to the 0 power, which is 4 times 1, which is 4. But you don't have to plug anything in. It will always be this one right here. Okay. For the 7th term, you say A sub 7 equals 4 times 5 to the 7 minus 1 power. I would simplify that 7 minus 1 to a 6. So 4 times 5 to the 6th power is 62,500. Any questions on that? Do you see how much of this quiz is on the 7-8 that you just learned? There's a lot of pieces to it, okay? Make sure if you have questions that you ask. 5 and 6, it says write the explicit formula for each geometric sequence, and I gave you the formula. So now you're just going to plug in to that formula 2 things. What are the 2 pieces that we have to replace? A sub 1 and R. Okay, you're going to replace those. Everything else stays the same. So what is your A sub 1 on number 5? 1. This is your A sub 1, the first term. So it's going to be A sub n equals 1 times what? What is R?
6.
How do you get 7? It's what you're multiplying by. 1 times 7. 7 times 7 gets you to 49. 49 times 7 gets you to 343. If you don't see that, your process is this: the second divided by the first, the third divided by the second. Okay, if they're the same all the way through, that's your common ratio. So I go 1 times 7 to the n minus 1 power. This is what you should write down for me. Don't ditch the n's, okay? N should be n in the formula. So that if I wanted you to find the 100th term, you could plug in the number 100. If I wanted you to find the millionth term, you could plug in the number 1 million, okay? Okay, number 6, similar idea. You say a sub n equals what? 81, your first term. This is your a sub 1. So 81. Then what? How am I getting from 81 to 27, 27 to 9, 9 to 3? It's not 3. It's 1/3. It's 0.3 repeating, but don't do the 0.3. Make it the fraction. You go 27 divided by 81 is 0.3 repeating. 9 divided by 27 is 0.3 repeating. Turn that into a fraction. Do the fraction to decimal button on your calculator, and it will tell you 1/3. To what power? N minus 1. Okay, this is your formula. Don't plug anything in for the n's unless I tell you find the 7th term, find the 12th term, find the whatever term. Then you plug a number in. But if I ask you for the formula, that's the formula. Any questions on that?
Wait, can you go to 5 really quick? There's one. Okay, yeah.
Okay, this one says fill in the table and graph the exponential function. So remember with exponentials, there's an asymptote. There's some line that it's never going to hit. You're going to drop in these 5 numbers to figure out what your y value will be. So the first one is 4 to the negative 2nd power. What does a negative exponent do? It moves it down. It flips it, okay? So this is going to be 1 over 4 squared. What's 4 squared? 16. So this is 1/16. That's your y value on that one. Okay, the next one, 4 to the negative 1st power. So I'm just plugging into that formula. What's 4 to the negative 1st? Not negative. It flips it. 1 over 4 to the 1st. So that's 1/4. Yes.
What is the button to turn a decimal into fraction?
It's like a F to D. I think, is it the PRB button? But the second of that? Is that where it is?
I think so.
Yeah. Okay, what's anything to the 0 power? 1. So that's 0, 1. 4 to the 1st power is 4, and 4 to the 2nd power is 16. Don't worry about if it's a 2/16, that's way off the page. Just don't graph that one, okay? If there's one that's way off, just leave it be. This is the point -2, 1/16. That's going to be way down here. Okay, barely above the line there. -1, 1/4 is going to be a little bit higher, but not much. 0, 1 is this point. 1/4 is that point. And then 2/16 is way off the page. I'm not even going to graph it. So your curve, it's exponential, right? It's a really sharp turn. Your axis of symmetry then, this is the x-axis, is our axis of symmetry, which it will be every time for you guys. Any questions on that, how you graph those?
On the play, it's the same if you want, like, you can't graph because it's too many, or is it going to, like, fit in the graph?
I don't remember. But if there's one that's just too big, just leave it off. I don't mark you off for that. I don't remember what numbers I used on the quiz one, so I'm not sure. Okay. if you're not working with me right now, you might want to pay attention to this because I want you to see it both ways. Numbers 8 and 9, you're trying to determine linear or exponential. What does a linear graph look like? A straight line. What does an exponential graph look like? That sharp curve, right? All of a sudden it takes off one way or the other, or shoots down one way or the other. Do you remember in a table how we could tell? What? Multiplying or adding which one? X or Y? Your Y value. So the X value is always going to be +1 on these. Okay, so that doesn't matter. We're not really looking at the X value. We're trying to determine when your X is constantly changing like that, then what is your Y doing? So to get from here to here, or here to here, or here to here, what are we doing? You're adding 2. So if you're adding the same thing every time, is that linear or exponential? It's what? It's linear. Why? Because you're adding the same amount. Okay? If it was exponential, you would be what? Doing what? Multiplying the same amount. Okay? Okay, so look at this one. Y equals 4 times 2 to the x power. Is that linear or exponential? This is exponential. Why do you know this is exponential? Yes, your variable is an exponent. Okay, what if it was y equals 2x plus 7? Is that linear or exponential? That's linear. Why is that linear? What? Your x isn't an exponent. You could explain it that way. You could say when graphed, it's a straight line. Okay, or you could say it's in slope-intercept form, would be fine. Okay, so just make sure you know the difference between those. If you're adding the same thing every time, it's linear. If you're multiplying by the same each time, it's exponential. So far, so good? Okay, so here's what it looks like on the quiz. I tell you, use this formula, or I tell you, use this formula, or use this formula, or use that formula. So I will do the exact same thing on the quiz. Take a look at this first one. It says the library, is going to start loaning out iPad chargers. It currently has 8 portable chargers, but they plan to triple that number every 6 months. Here's the kicker. You ready for this? How many chargers will they have after 2 years? Okay. I bolded triple. What is triple supposed to represent here? What? Multiplying by 3. What does that represent in this equation? It's your B. That's your growth factor. Okay, this is your growth factor, or your B in the equation. So whatever it is changing by is your B. What is your A? That's the 8. That's the starting amount. Okay, which in this case is 8. So if I set this up, my equation is y equals 8 times 3 to the x power. Do you see how that looks just like this one? A times b to the x. Your job is, once you've done that, figure out what x should be. And that takes a little bit of effort. It's tempting to just plug in a 2, but notice that it says it's going to triple every 6 months. So every 6 months it's tripling. They're saying after 2 years, how many times is that? That's 4 times. Okay, so don't just look at the number and go, oh, it's 2. It's 4 times if we're doing it every 6 months. 6 months, a year and 6 months, 2 years. That's 4 times that it tripled, okay? So 8 times 3 to the 4th power, and what do you get? We would have way more, we'd have more chargers than we have people at the school. 648 chargers. Okay. All right, number 11, it says the value of a car is decreasing, which is how we know we're using the subtraction formula. Find the value of, or the value of your car is $34,000. What will it be worth in 6 years? So if this is our formula, what is A? 34,500. Y equals 34,500 times 1 minus, what is R? 0.09. 9%. If you divide by 100, you got to drop a 0 in, okay? 0.09 to the t power. If you want to simplify that, 1 minus 0.09 is 0.91. So you may write it like this, or you may write it like this. I honestly, I don't care one bit which one you do. So it's up to you. If you want to subtract that and write it like that, you totally can. What are we plugging in for t? 6. So you're going to go y equals 34,500 times 0.91, or 1 minus 0.09 to the 6th power. And when you plug that in, what do you get? What's your car worth 6 years later? If we're talking dollars and cents, $19,591.49. Don't forget to label, okay? This is dollars, so put a dollar sign out in front. I want to know that you understand what it is we're talking about. Leave your phone up here. Okay, number 12. This is the compound interest equation. And again, it's going to be sitting right at the top of the problem for you, ready to go. You just have to know where things get plugged in. So this one says you have $3,000. Uh-oh. There we go. $3,000. Just kidding. $3,000. Paying 4.5% interest compounded annually. Find the balance in 9 years. What number represents annually in compound interest? 1. It's your n, but it's the number 1, okay? So the beautiful thing about this is if it's annually, you actually don't have to use this one. You could use the, not that. It's the same as saying y equals a times 1 plus the rate to the t power, because you're just ditching the ends because your ends are 1. If you don't want to have to decide that, just plug it in and plug in ones, okay? So if we set this up, y equals, what is a? 3,000, your starting amount, times 1 plus, what's your r? 0.045. You need to move it 2 decimal places back. So 0.045 divided by the number of times it's compounded. Annually is just once. To the 1 times what? What's your t? This should be a 9. Okay. So plug that into your calculator. Again, I would just not even plug in the 1. I would plug this in as 3,000 times 1 plus 0.05 to the 9th power. Plug that into your calculator, because ones don't change it. Yes, I would absolutely do that. Did you get this? $4,458.29. Okay, last one. It says your cousin has $8,000 paying 4% interest compounded monthly. What is it 6 years from now? What is A? 8,000. So your starting amount, 8,000 times 1 plus, what is R? 0.04. What is N? It's not 1. 12. Monthly would be 12 times. So divided by 12 to the 12 times 6 power. I would not plug that in as 12 times 6. I would plug in 12 times 6, which is 72, and I would take it to the 72nd power. You should absolutely plug this one in because this is the one that gets done wrong a lot. 1 plus 0.04 divided by 12 to the 72nd power. I got this number. Did you get that number also? $10,165.94. If you're not, you should call me over right now so I can show you how to plug it into your calculator. Okay? Questions on that?